Hello students, how are you? Today I want to take up the hydrocarbons. What are hydrocarbons? Hydrocarbons are the first and foremost compounds of the organic compounds. These are alkanes, alkenes and alkynes. The basic compounds of organic chemistry, that is the compounds with only carbon and hydrogen, are called hydrocarbons. In them, the first class of compounds are alkanes. Alkane, ane means saturated. They will have all single bonds. Okay. These alkanes are the first class of compounds, and as these are saturated, they are unreactive. They are unreactive. That's why these are also called as paraffins. Para means a little affinity towards any of the reagents. That's why alkanes are called paraffins. The general formula of alkanes is CnH2n plus 2. CnH2n plus 2, where n is the number of carbon atoms. Okay, and in alkanes, all the carbon atoms undergo sp3 hybridization, because in alkanes each carbon is surrounded by 4 sigma bonds, 4 single bonds. That's why this carbon, all single bonded carbon undergoes sp3 hybridization and it will have tetrahedral structure, and this will have CC bonds and CH bonds. What are the properties of this CC bond and CH bond? The CC bond length is, it is a single bond length 1.54 angstrom units and its bond dissociation energy is 345.8 kilojoules per mole. Okay? And similarly, CH bond length 1.11 angstrom units and its bond dissociation energy is 412.8 kilojoules per mole. Okay students, this is the introduction of alkanes. Now let us see the preparation of alkanes. Preparation. In the preparation, the first one is hydrogenation of unsaturated hydrocarbons. Hydrogenation of unsaturated hydrocarbons. Unsaturated hydrocarbons are alkenes and alkynes. Alkenes and alkynes. So, alkenes and alkynes can be hydrogenated. Hydrogenation means addition of hydrogen in presence of a catalyst. The first one is hydrogenation. Hydrogenation with nickel or platinum or palladium catalyst. Nickel or platinum or palladium catalyst, that is, the reagent is H2 in presence of any one of these metals. This reaction is called as Sabatier-Sanderens reaction. Sabatier-Sanderens reaction. Okay students, now if we take the first member unsaturated hydrocarbons means it should have minimum 2 carbon atoms. So if we take the first member CH2 double bond CH2, CH2 double bond CH2, what is that? It is called ethylene. It is called ethylene or ethene. Ethene plus 1 mole of hydrogen in presence of nickel or platinum or palladium catalyst gives, each one of the hydrogen will be added to 1 carbon atom. So, it forms CH3, CH3. This is ethane. It is ethane. This is ethene. Unsaturated hydrocarbon ethene. 1 mole of hydrogen is added. It is generally the adsorption catalysis, and this is also a heterogeneous catalysis reaction, because The physical state of catalyst is solid and these two are gases. So, it is an example for heterogeneous catalysis reaction. Okay students, in this heterogeneous catalysis reaction, the hydrogenation will be a syn addition. It is a syn addition. Syn addition means both the hydrogens are added on the same side of the double bond. Now let us see the example for that. If you take the higher alkene, we can observe this syn addition. If you take the higher alkene, let us take CH3, C double bond C, CH3, H or C2H5, C2H5. This is an unsaturated compound. It is 2,2,2. It is a 6 carbon structure. It is hexene. Hex, these two are substituents on 3rd and 4th carbon atoms. This is 3,4-dimethyl, 3,4-dimethyl hex 1,2,3,3-ene. This is the IUPAC name of this structure. If you add 1 mole of hydrogen in presence of nickel catalyst, what we get is C2H5, C, and both the methyl groups will be on the same side, CH3, CH3 and C2H5, and we are adding 2 hydrogens to make it a saturated molecule. So, both the hydrogens will be on the same side of the double bond, on same side. That is why this is a syn addition. It is a syn addition. This results in the formation of a meso compound. It is a meso compound. Syn addition results in the formation of a meso structure. Okay students? Hydrogenation can also be done by using Raney-Nickel catalyst along with concentrated NaOH. What is this Raney-Nickel? Raney-Nickel is an alloy of aluminium and nickel. This aluminium and nickel along with concentrated NaOH is a very good, very strong reducing agent which supplies hydrogens to the unsaturated compounds. This is the reaction between Raney-Nickel, the alloy, and sodium hydroxide. It forms sodium aluminate and liberating the hydrogen gas. This hydrogen gas will be reacting with the unsaturated hydrocarbons. Ethylene plus this hydrogen from the catalyst mixture, it forms ethane, CH3, CH3. We can have a cyclic compound also. Cyclic unsaturated compound also can be converted into a saturated molecule by using this Raney-Nickel. This is cyclopentene, cyclopentene. This is Raney-Nickel, NaL, Ni in presence of NaOH which supplies hydrogens, and it makes it that hydrogen reacts with the unsaturated bonds, the pi bonds, and make it saturated to make it cyclopentane. Cyclopentane. This is the hydrogenation of unsaturated hydrocarbons. Here we have taken only the double bonded compounds. We can take the triple bonded compounds also. That means alkynes. Alkynes also can be hydrogenated. If you take it, acetylene, ethine. Ethine with 1 mole of hydrogen in presence of nickel catalyst is converted. Here it is a triple bond, so 1 pi bond is broken. So it forms first ethene, and with 1 more molecule of hydrogen, the reaction is continued. The reaction continues to give a saturated molecule, CH3, CH3. So, by taking alkynes also, we can get the alkanes by continuous hydrogenation, complete hydrogenation. Okay. On controlled hydrogenation, we get double bonded compounds, that is the alkenes, but on complete hydrogenation, we get alkanes. Okay, students. This is one of the methods. Another method is Wurtz reaction. Wurtz reaction. Wurtz reaction is alkyl halide. Alkyl halide is reacted with sodium metal in dry ether. Sodium metal in dry ether to get an alkane with double the number of carbon atoms. This can be easily written as we are taking 2 moles Rx plus this Na, we have to take 2 moles of sodium, we get Na, 2NaX. So, 2Na plus XR. Let us write in the reverse manner so that it forms, the sodium will combine with 2 halogen atoms and these R will join together to form an alkane with double the number of carbon atoms. For example, if we take methyl chloride, 2Na plus methyl chloride again in presence of dry ether. Dry ether is the solvent used for this. The ether should not have moisture because that moisture will react with the sodium. So, ether should be very, very dry. Dry ether is taken as the solvent for this reaction and these will react. This methyl and methyl will join to form ethane CH3 plus 2NaCl. 2NaCl. This is a very important reaction. The limitation for this reaction is we cannot prepare methane. Methane cannot be prepared because we are getting an alkane with double the number of carbon atoms. So, methane cannot be prepared by Wurtz reaction. What is Wurtz reaction? Alkyl halides are reacted with sodium metal in dry ether to get an alkane with double the number of carbon atoms. Okay. So, we are getting, if we take methyl halide, we get ethane. If we take ethyl halide, C2H5Cl, 2 moles of C2H5Cl, 2Na. What we get here? This ethyl and ethyl groups will join together to form an alkane with double the number of carbon atoms. In the parent, it has only 2 carbon atoms, but in the product, it will have 4 carbon atoms. C2H5. So, it is C4H10. It is butane. Plus 2NaCl. So, it is a very, very important reaction for the preparation of alkanes, Wurtz reaction. Alkyl halides, from the alkyl halides we will prepare an alkane with double the number of carbon atoms. In this reaction, we have taken the identical alkyl halide, this methyl chloride and methyl chloride. We can take 2 different alkyl halides also. That is known as crossed Wurtz reaction. It is called crossed Wurtz reaction. What is crossed Wurtz reaction? If we take 2 different alkyl halides which will be reacted with sodium metal in dry ether to get an alkane. But here we get a mixture of alkanes. For example, if we take methyl chloride, 2Na plus ethyl chloride, C2H5, what we get? This chloride, these 2 chlorides will react with sodium and methyl and ethyl will join to form propane, CH3, C2H5, which is nothing but C3H8, which is propane. It is propane. We are getting an alkane with the sum of the carbon atoms equal to the sum of the carbon atoms present in the alkyl halide. But here there is one difficulty. What is the difficulty? This methyl chloride and ethyl chloride, not only they react. One methyl chloride, we cannot take a single molecule. We cannot take a single molecule of methyl chloride and ethyl chloride. We will take 1 mole or half mole. A mole consists of Avogadro number of molecules. So, a methyl chloride will react with methyl chloride, 2Na plus ClCH3, and ethyl chloride will react with ethyl chloride, C2H5, and methyl chloride will react with ethyl chloride. So, what we get here? Here we get an ethane. Methyl and methyl join together to form ethane. CH3 and CH3, ethane. And ethyl and ethyl join to form butane, C2H5 and C2H5, butane. And methyl and ethyl join together to form propane. Propane. Ethane, propane and butane, we are getting 4 alkanes in the same reaction. If we do the crossed Wurtz reaction. What is crossed Wurtz reaction? The reaction between 2 different alkyl halides with sodium metal in dry ether to get the alkanes. Here we get a mixture of alkanes which is very difficult to separate, because these are all alkanes, these are all homologous series. They will have similar physical and chemical properties, only they differ very little in their boiling points. As their difference in the boiling points is very less, it is very difficult to separate them. So, crossed Wurtz reaction cannot be, generally it is not adopted for the preparation of alkanes, only simple Wurtz reaction. Simple Wurtz reaction is, by taking a single alkyl halide, we will prepare an alkane with double the number of carbon atoms. And there is one more difficulty in this reaction. We cannot take tertiary alkyl halides for the preparation of substituted alkanes, because if you take a tertiary alkyl halide, instead of adding together, they undergo elimination reactions. Tertiary means CH3C. This is a tertiary alkyl halide. This tertiary alkyl halide in sodium and dry ether, it undergoes elimination reaction to form an alkene, CH3. This chlorine and one of the hydrogen will be eliminated. These are eliminated and there is a double bond formation between this carbon and this carbon. So, it is not preferable to take a tertiary alkyl halide for the preparation of alkanes. Tertiary alkyl halides are giving an alkene instead of alkanes. Okay students, in the next class, in the next video, I will take the other reactions of preparations of alkanes. Okay, have a nice day.